Hello buddy, so I welcome you all to my channel. Already we have started dimensional analysis. This is the part 2, lecture number 2 on dimensional analysis. Actually this is the lecture number 7 for our chapter units and measurement. Okay, so today we will learn the very important concept of dimensional analysis, that is principle of homogeneity. Okay, so we will try to understand that and we will solve some numericals based on that. Okay, so today very important concept related to NEET, JEE board, everything we are going to cover. Okay, so watch this video from beginning to end. Okay, write everything and don't forget to subscribe my channel if you are not subscribed. Okay, and forward the link to your friends. Insist or convince others to subscribe this channel. Okay, so let's start. So write down the heading, that is dimensional analysis. Those who have not attended previous video, please watch that video, because the basic concept related to dimensional analysis we have covered in that. Okay, so based on that this lecture is there. Okay, so dimensional analysis part 2. Part 2. This is a topic, very important topic from units and measurement. Okay, now look. So those who have not attended previous video, not watched previous video, okay, they can go to my channel, type dimensional analysis Prakash Vahide. Okay, so you will get that video. But I will make you understand here also what is the dimension. Dimension is suppose the dimension of length is what? L. Dimension of mass is what? M. In a square bracket this is written. Dimension of time. Okay, these are the three basic base fundamental quantities. There are actually 7 fundamental quantities. Out of 7, 3 are main. Okay, so main means they appears in many derived quantities. Okay, others sometimes seldom they occur. Okay, but these are the 3. Many times, most of the times it is a combination of these 3, either 1, 2 or 3. Okay, so this is T. And powers of these symbols is called dimensions of that physical quantity. Suppose for example speed. Speed is distance upon time. Okay, distance upon time. So distance means length. Okay, so length means what? L. L divided by time means T. Okay, so this will be L 1 T minus 1. Okay, like this. So this is the dimension. M also can be written M0, M is absent, L1 T minus 1. So this is the dimensional formula for speed. Dimension means what? Powers of this. Okay, so dimension of speed is 0 in terms of mass, dimension of speed is 1 in terms of length, dimension of speed is minus 1 in terms of time, in this way. Okay, so this is this concept we have learned in the previous video, and lot many we have derived dimensions of lot many physical quantities. Okay, so you watch that video. Now what we are going to start today is principle of homogeneity. Okay, principle of homogeneity. So what is principle of homogeneity? Principle of homogeneity. Principle of homogeneity. So what is this principle? This principle says the physical quantities or the terms, not physical quantity, terms can be combination of different physical quantities. The terms can be added or subtracted when or only when they have same dimensions. They have same dimensions. They have same dimensions. Means what? A plus B is equal to C. Then these two are added. It means their dimensions are equal. Okay. So dimension of this A is equal to dimension of B. Whatever may be the physical quantity. It may be force, anything, force or momentum or anything. Okay. So dimension of A is equal to dimension of B, and that is equal to dimension of C, not A plus B. Dimensions. Though C is equal to A plus B, dimension of A is equal to dimension of B, dimension of is equal to dimension of C. So how many terms? This is one term, this is another term, and this is the third term. So another way to express this principle of homogeneity is what? The dimensions of each term in an equation are equal. Okay. So another way is what? This is one way to explain. Another way is what? The dimensions. The dimensions of every term in an equation are equal. Okay. So if A minus B is equal to C or D. Okay. So dimension of A is equal to dimension of B is equal to dimension of D. Or suppose if one example is x is equal to z by y, suppose. Okay. Or x plus y plus z is equal to suppose A, or let us A by B, dimension x plus A by B is equal to y, suppose. So dimension, this is one term, this is another term, this is third term. So dimension of x is equal to dimension of which term? This term, complete term, is equal to dimension of y. This is the meaning. Okay, dimension of A by B is equal to dimension of y, dimension of x. Suppose x plus y into z is equal to c, suppose. Then x, dimension of x, this is one term, is equal to dimension of another term yz, okay, is equal to dimension of c. Getting? So this is the meaning of these two sentences. We don't bother about this product and this multiplication. We bother about the terms. So terms can be added or subtracted when they have equal dimension. Otherwise we cannot add or subtract. Okay. Another thing is dimension of every term is equal. Clear? No doubt in this. Simple. Okay. So we will solve some numericals so that we can remember this equation or this principle easily. Note down this. Clear? No? Everything is clear? Board is clear? If video is blur, as I told you many times, you watch on horizontal mode, and here 3 dots are there on the top of your video. Okay, so you click on there. Here you can set your resolution. Okay, so normally for 540 or maybe 720 is the best resolution, 720p. So you watch your videos on 720p. Okay, if network is good, no problem, automatically it will set the good resolution. But if network is not good, so it will be little bit blur. Okay, but that setting you can change. Clear? Can I erase this now? So after solving some numericals, we will see the applications and limitations of this dimensional analysis, possibly in this video or maybe in another video. Okay. Now look. Now look. So example number 1, find dimensions of x and y. Find dimensions of x and y in the equation given. Okay. So equation is, let us take ax plus by is equal to z, ax plus by is equal to z, where or let us take only 2, no problem, ax plus b is equal to z. Now where we have to find x and y, no? Here we will take y. Ax plus y is equal to z. So we have to find out dimension of x and y, where a is equal to acceleration, okay, and z is equal to let us say distance. Let us say distance. Find the dimension of x and y. So to find dimension of x and y, we can use principle of homogeneity. Now look how to solve. So equation is ax plus y is equal to z. Okay. So dimension, now by using principle of homogeneity, what we can write? Dimension of x is equal to dimension of y is equal to dimension of what? Z. Yes or no? Is equal to dimension of z. Now what is z? Z is the distance. Okay. So dimension of y is equal to what then? Dimension of z means, what are the dimension of z? Distance means what? Length. Okay. So length to the power 1. Got the dimension of y? So dimension of y is equal to dimension of L. One answer we have got. Okay. Now another equation we can write is what? So ax is equal to, either you take this or this, no problem, because both dimensions are known now. So ax, dimension of ax is equal to dimension of what? Z, which is equal to L. Clear? Now what is a? Dimension of a. Dimension of a means acceleration. What are the dimension of acceleration? Acceleration is equal to what? Velocity upon time. Velocity is equal to what? Distance upon time. Means it will be what? Distance upon t square, means L t to the power minus 2. Okay. So a, dimension of a into dimension of L t to the power minus 2 is equal to dimension, this dimension. Okay. Now dimension of a, we can write dimension of a are written, no? So here x. Dimension of a, we have written this. This will be what? X. So dimension of x is equal to what? L divided by this L t to the power minus 2. So ultimately what you will get? M is 0, L, this 1 minus 1, 0. Are you getting? L1, this here, L1. So this we can cancel, or L to the power 1 minus this plus will go in the numerator and it will become minus 1 minus 1, 0. Now t, there is no t, so this t 0 in the numerator, so this will be 0 minus will be plus 0 plus 2. So t to the power 2. So what are the dimension of x? M0, L0, t to the power 2. And what are the dimension of y? Dimension of y are L. Clear? So in this way we can solve the numerical. Got it? Got it? Can I erase this? Note down this. We will solve another numerical. Note down this. Note down this. We will solve another. Example number 2. Okay, find dimensions. Find dimensions. Find dimensions of A and B. If what is the expression? If V is equal to A plus BT, where V is velocity, T is time. Okay. Find dimensions of A and B if V is equal to A plus B, where V is velocity, T is time. How to find? Just like previous. So V is equal to A plus BT means dimension of V is equal to dimension of A is equal to dimension of BT. Dimension of each term are equal. So what are the dimension of V? Dimension of V are what? V is equal to what? V is equal to distance upon time. So distance means L, T means time. So L T to the power minus 1. So L T to the power minus 1, okay, is equal to dimension of A. So here we have got dimension of A. Now V is equal to what? BT. Yes or no? So dimension of L T to the power minus 1 is equal to dimension of B into dimension of T is what? T is time, means T. So dimension of B is equal to what? This L T to the power minus 1 upon T. So this will become what? This T will go on this side, no? So this will be what? L T to the power minus 1. This will go in the numerator and become minus 1, minus 1, minus 1, minus 2. Okay. So these are the dimension of B. So dimension of A are L T to the power minus 1, M you can add if you want. Okay. Dimension of B is equal to M0 L1 L1 T to the power minus 2. Got it? So in this way you can solve the numerical. Clear? Note down this. Can I read this? So okay. So example number 3. Find the dimensions of A, B, C, D and E in x is equal to A plus BT plus CT square plus last term dt cube by E plus T. This complete one term. Okay. So how many terms are there? 1, 2, 3, 4, 5 terms are there. Okay, where x is the displacement and t is the time. So how to solve this? How to solve this? Solution for example number 3. Now look, as per dimensional homogeneity concept, dimensions of every term equal. Dimension of x, let us write dimension of x, dimension of x is equal to what? Dimension of A, okay, is equal to dimension of this term BT, okay, is equal to dimension of CT square, okay, and this is equal to dimension of this complete term dt cube divided by E plus T. Clear? Okay, clear? Clear? Now let us equate one by one. So dimension of A is equal to dimension of x. Dimension of A is equal to dimension of x. And what is the x? X is the displacement. Displacement means L. Okay, so this is one answer. Dimension of A is equal to L. Now dimension of this term, dimension of BT is equal to dimension of x. Okay, so this will give you L. So ultimately what we can write from this? dimension of B into dimension of T is equal to dimension L. T means what? Time. So this dimension is T. So ultimately dimension of B is equal to dimension L divided by this T. Yes or no? So this is equal to dimension L T to the power minus 1. So this is the dimension of B. Now dimension, this term is equal to this term again. This is first, this is second, now third. Third will be what? Ct square is equal to dimension x, which is equal to L. So dimension of C into dimension of T, T square means T square is equal to L. So ultimately what we can write? Dimension of C is equal to dimension L divided by this will be T square. Okay, so this will be L and this will be T to the power minus 2. Clear? Clear? Now this term is equal to again this. But before that in this term E plus T, let E plus T is equal to K. Let us assume. Now this is one equation, means and there are how many terms? 1, 2, 3 terms. So dimension of E is equal to dimension of T is equal to dimension of K. Yes or no? So from this dimension of E is equal to dimension of T, okay, is equal to dimension of K. If dimensions are equal, only then we can add, no? Okay, so that will give you this expression. So from this we can write dimension of E equal to dimension of T means what? T means time, so T. So which is equal to dimension of K also. Dimension of K is equal to T, dimension of E also T. Means complete term E plus T is K, means dimension is also T. It does not mean that this plus this means a T plus T square, no. Clear cut I have mentioned here. Assume E plus T is equal to K, and this we can do when these dimensions are equal, means dimension of K is same as of this means T. Okay, now look, now D, so here one answer we have got, dimension of E is equal to T, this is one answer. Okay, so A we have calculated, B we have calculated, C we have calculated, E we have got. Now D, for D, dt cube divided by E plus T, this is equal to what? Dimension of x. You can equate this or this. X means what? X means L. So from this dt cube divided by E plus T, what is the dimension of E plus D means K, and dimension of K is what? T. Okay, so T, yes, is equal to L. So this dimension of D into dimension of T cube means T means time, means T cube, and this is in the denominator T raised to 1. So 3 minus 1, this will become minus 1, no. So 3 minus 1, 2. So T to the power 2 is equal to L. So ultimately dimension of D is equal to this L divided by this T square. This will go on this side in the denominator. Now L T to the power minus 2. So ultimately this is the dimension of D, this is the dimension of E, this is the dimension of C, this is the dimension of B, and this is the dimension of A. So in this way we have calculated all dimensions. In this way we have to use principle of dimensional homogeneity and we can solve the example. This is very important, this part. Here lot many students do the mistake. Clear? No doubt in this? Note down this, we will solve example number 4. Can I erase this part now? Now you pause the video and you can note down. Now look, example number 4. Find the dimensions of A by B in the equation P is equal to A T square, A minus T square divided by Bx, where P is the pressure, T is the time, X is the displacement. How to solve? Now here also A minus T square is equal to, let us say, K, means dimension of A is equal to dimension of T square is equal to dimension of K. Yes or no? As per dimensional homogeneity, we can add or subtract the terms, not physical quantity, terms when the dimensions are equal. So dimension of A must be equal to the dimension of T square. So from this, dimension of A we can get is equal to T square. T is a time, sorry, here also time. So time means what? Time means what? T square. So dimension of A is what? T square, which is equal to dimension of K also, same. Okay. Now P is equal to pressure. What are the dimension of pressure? Pressure means force upon area. What are the dimension of force? I told you to remember m L T to the power minus 2. Otherwise you can calculate F is equal to ma. Put the dimension of A, put the dimension of acceleration. Force is equal to ma. Then ma means what? V by T. Okay. Again m into V is what? Distance. Distance means L by T divided by this T. So ultimately m L and T to the power minus 2. Yes or no? So these are the dimensions of force divided by area. What are the dimension of area? L into L. So L square. So this is L square. So ultimately dimension of P is equal to what? m0 L 1 minus 2 minus 1 T to the power minus 2. These are the dimension of pressure, which is equal to what? Which is equal to this. So dimension of P is equal to dimension of this complete term, P minus A minus T square divided by Bx. Clear? So P is m0 L minus 1 T to the power minus 2. So this is equal to A minus T square. A minus T square is K, and dimension of K are T square. T square. T square divided by B, dimension of B into dimension of X. So ultimately T square divided by dimension of B into X. X is a displacement. So dimension of displacement means length L. Okay. So we want B. So dimension of B is equal to this T square divided by this m0 L to the power minus 1 T to the power minus 2 into this L. This B will come here, this will go at the place of B, remaining is as it is. Okay. So simplify this, m it will go in the numerator, it will become 0, no, so 0, it will remain 0. Now L here itself, minus 1 plus 1, minus 1 plus 1, 0. Okay, so L 0. Now T, 2 minus 2, so this will go up, plus 2, 2 plus 2, 4. So L to the T to the power 4. So these are the dimensions of B. But this is not the answer. Answer, we have to calculate A by B. A by B. How we can calculate? I will write here. So A by B is equal to dimension of A. Dimension of A are what? T square. Dimension of A T square. Dimension of B T to the power 4. Okay. So 2 minus 4 minus 2. Okay. Minus 2. m0 L0. So these are the dimensions of A by B. Got it? No doubt in this? Clear? Clear? Note down this. We will solve another. So example number 4, find the dimensions of alpha. I think example number 5 na, whatever it may be. Find the dimensions of alpha in this p is equal to p0 into e to the power minus alpha t square, where p is the distance, p0 is the displacement, t is the time. How to solve? How to solve? Now in the expression p is equal to p0 e to the power minus alpha t square, so this power power minus alpha t square is what? Is a number, always, yes or no? Always it is a number, whatever it may be, combination, it is a power of something, means always it is a 0. Powers, this is basically power, no? Power means a number, means dimensionless, okay. So dimension of alpha t square are what? m0, l0, t0. Remember this. Remember this. Alpha t square is equal to m0, l0, t0. Now calculate dimension of alpha, because dimension of t we know, t is a time. So t is a time. So alpha into dimension of t square, time means t square. This is equal to m0, l0, t0. Okay. So alpha is equal to what? m0, l0, t0 divided by this t square. So ultimately what you will get? m0, l0, 0 minus, this will become minus 2 in the numerator. So 0 minus 2 is minus 2. Okay. So dimensions of alpha are what? m0, l0, t to the power minus 2. Minus 2 in a time. Dimension of alpha are minus 2 in time. Okay. Clear? No need to use this and this, because further they have not asked anything, they have asked only find the dimension of alpha, and we have got the dimension of alpha. Ultimately another concept I will tell you, this also complete term, this alpha by t is a dimensionless, but this is also dimensionless, e to the power something, minus alpha t square, this complete also a dimensionless, this is also dimensionless, this is also dimensionless. Okay. This is also dimensionless. Okay. Remember this. Note down this. We will solve another numerical. We will solve another numerical. Okay. So now look. Example number 3. Find the dimensions of beta in p is equal to alpha by beta e to the power minus alpha z by k z, k theta, where p is the pressure, z is the distance, z is distance, theta is the temperature, k is a Boltzmann constant, its unit is given, some options are given. How to solve? How to solve? So first of all what we need is, we need the dimensions of given terms. Pressure, what is the dimension of pressure? We have to calculate dimension of alpha, no? So let us write dimension of P. Pressure is what? Force upon area. Force upon area. Dimension of force are m1 L1 t to the power minus 2. Area is L square. So dimension of pressure are m1 L minus 1 t to the power minus 2. Correct? m1 L1 t to the power minus 2 force. If you do not remember, you can calculate. Mass into acceleration. Acceleration is velocity upon time. Velocity is displacement upon time. Like that. You go on and calculate. So minus 1 minus 2 minus 1. Okay. So this is the dimension of pressure. Then dimension of z. Dimension of z is a distance, means L. Means L. Then dimension of temperature, theta. Temperature. So this is a theta to the power 1. We can write k, but k another option is there. We can write theta for temperature. Then dimension of k. So k is a Stephan Boltzmann constant. or Boltzmann's constant. How to, if you don't know the dimension, unit they have given, by using this unit you can calculate the dimension of the k. K is what? Kg m square. Kg means m, meter means length square, divided by s means time, t square, temperature. Here additional base quantity is there, that is temperature. So Kelvin means temperature. So for temperature we are using theta, so theta to the power 1. Okay, so these are the dimensions of k. These are the dimensions of k. We can simplify this if you want. M L square t minus 2 theta to the power minus 1. Okay, so like this we can simplify. Now we use this concept, this power alpha z by k theta is a dimensionless. In the previous numerical we have seen. So these dimensions are what? M0, L0, T0. Okay, so dimensions of alpha into dimensions of z, L, divided by dimensions of k, M, L square, t minus 2 theta to the power minus 1 into theta is equal to M0, L0, T0. Okay, so here again simplify alpha, this L divided by theta to the power base is theta minus 1 plus 1 becomes 0. Okay, so we can eliminate that term. So M L square t minus 2 theta we can eliminate. This will be equal to what? M0, L0, T0. Okay, now after this what you can write? This alpha into or simply what you do? This alpha is equal to this M0, L0, T0 into this term will go on this side. So this will be M L square t minus 2 divided by this term, that is L. Okay, no problem. This will go here, this will go here. Okay, so dimension of alpha is equal to M0, 0, 1, so M1, L 0, 2, and this is 1 will go on this side minus 1, so 2 minus 1 is 1, so L to the power 1. Then T 0 minus 2, so T to the power minus 2. So these are the dimensions of alpha. These are the dimensions of alpha. Okay, dimension of alpha. Now what we have to calculate? We have to calculate dimension of beta. So now use this concept, dimensions of e to the power minus alpha z by k theta, this term e to the power something, this is also dimensionless, power itself is a dimensionless, and e to the power something, some power, this is also a number, means dimensionless, means dimensionless, M0, L0, T0, complete. Okay, so no need to write that. So ultimately what we are getting? P is equal to alpha by beta. This is dimensionless. If you want to write, you can write M0, L0, T0, otherwise no, don't write, no problem. Okay, now from this we can calculate P, dimension of P. P is what? P, dimension of P, pressure we have calculated. What is this? This is M1 L t to the power minus 1 t to the power minus 2. This is a P is equal to alpha. Alpha, what are the dimension of alpha? M1 L1 t to the power minus 2 divided by beta, dimension of beta. So dimension of beta you take on this side, we want dimension of beta. So this is equal to what? M1 L1 t to the power minus 2 divided by this term M1 L minus 1 t to the power minus 2. Okay, so this we can cancel, or minus 2, this will become plus 2, minus 2 plus 2 0, 1 minus 1 1, this will go become minus 1, 1 minus 1 0. Okay, otherwise you can cancel here, no problem. Okay, so ultimately L 1 minus 1, L this minus 1 will go here, will become plus 1. So 1 plus 1 2, so L to the power 2. So ultimately dimension of beta are what? They have given option in M and L. M, so there is no M, so M 0 L 2, so this is the option, M 0 L square, M 0 L square. Is it correct? Check again, option given is wrong. So this is the answer, this is the answer. Okay, our solution is correct, option was given was wrong, by mistake I had written minus 1, it is a plus 1, plus 2. Clear? Clear? So now look, y is equal to a sin omega t minus k, where y is a displacement, t is the time, find the dimension of a, omega and k, a, omega and k. Can you try? Can you try? Can you try? Now look how to solve. This term y is equal to a sin omega t minus kx, this term, observe this term, sin omega t minus kx is what? It is angle, it is angle, and dimension for angle, angle is what? Omega t minus kx is angle, no, and is angle, and angle is dimensionless, angle is dimensionless, angle is dimensionless. Okay, means dimensions of and this is also some angle minus another angle, so this term is also dimensionless, yes or no? So dimensions of omega t is equal to dimensions of these two terms are added, no, means the dimension of this and this term should be same. So dimension of this term into dimension of this term is equal to dimensions, what is the dimension? Dimensionless. This complete is a dimensionless. So M0 L0 T0. Clear? Clear? Now from this omega t is equal to M0 L0 T0. So dimensions of omega into dimension of t, t is a time, means t, is equal to M0 L0 T0. So dimensions of omega is equal to what? M0, this t will go on this side, it will become t minus minus L0 t to the power minus 1. So this is the dimension of omega. Clear? Clear? Now dimension of k, omega t, omega x, sorry, kx, kx is equal to M0 L0 T0. So dimension of k into dimension of x is L, x is what? X is also a displacement. X is also a displacement. They have not given anything, na? What we have asked? Dimension of A we have to find out, dimension of omega we have to find out, dimension of k we have to find out. Okay? So x is also a displacement or distance, we can say. So this is equal to what? Displacement means L, this is equal to M0 L0 T0. So ultimately dimension of k is equal to what? Is equal to what? m0, l minus 1 and t0. Yes or no? Yes or no? No, clear, no? Now, how to calculate dimension of what? What is remaining? A. Now, this complete term sin theta is also some value, means it is also dimensionless. This is also a dimensionless. Okay. So, y is equal to A. So, dimension of y is equal to dimension of A. Okay. So, y is what? Displacement. So, dimension of A is equal to L. So, this is dimension of A, this is dimension of K, and this is the dimension of omega. Clear? m0, l1, t to the power 0. Clear? So, in this way we can solve the numericals. So, here we will stop. Okay. In the next class we will see the limitations and some application of dimensional analysis. So, today we have completely discussed dimensional homogeneity concept. Okay. 6, 7 numericals we have solved. How many concepts we have learned? Dimension of every term should be constant, dimension of power is dimensionless, e to the power something is also dimensionless, angles are dimensionless, cos theta, sin theta, tan theta, that also dimensionless. So, using this you can solve any numerical now. Clear? Okay. You practice some more numericals and you will understand everything. Okay. So, you watch this completely thoroughly twice, thrice if you want, practice some numericals, and in next class we will solve, we will see another concepts, applications and limitations. Till then, goodbye. Thank you.